Hi, hello, good evening to everyone. I hope everyone will be fine. Thanks to joining in this session. Thanks to accepting our invitation, VNRVJIET Institute of Engineering and Technology. Thanks to the convener for accepting our invitation and coordinator, sir. So, VNRVJIET Institute of Engineering and Technology was established in 1995. It is established for the last 2 decades. This college will give so much brilliant students to the society. So, from the nationwide, it got all India 109th rank. So from Andhra Pradesh and Telangana, VNRVJIET Engineering College have a good name and it's almost a top college. So in this college, electrical department started at 1995. So we are offering BTech graduation and post graduation and PhD also. So JNTU Hyderabad recognized a research center in our college. So college, thanks to joining with Pantech Solutions, and today content is webinar on electric vehicle design using the Matlab. So myself, Srinivaslu Ala, I completed my MTech in Power Systems at JNTU Anantapur. And what are the contents today? What are the contents we're discussing here? Motivation to develop a battery electrical vehicle. In India, how to motivate to develop a battery electrical vehicle? Now, what are the key drives to growth electric vehicle in India? And switching to battery electrical vehicle from IC engine, what are the opportunities for Indian entrepreneurs and the types of motors, what are the innovative thoughts, challenges face battery electrical vehicle industries in India, what are the challenges we are facing, and reason, what are the reasons for shifted to clean mobility. We will discuss this content. From Pantech Solutions was originated by 2004. We have 7 branches across the country and 100 plus employees are working. We are conducting already 1200, more than 1200 workshops we conducted. We give a best knowledge to almost 8 lakh students. Our portfolio R&D research and development for industry projects, faculty development programs, hands-on training workshops, internships in plant trainings, short-term courses, and most of the value-added courses, academic project training by Pantech provide, customized design service and state-of-the-art, and in which areas we are giving the service to the engineering graduates and postgraduates and PhD scholars, in which area we are giving the service. So Internet of Things, artificial intelligence, embedded systems, robotics, VLSI, FPGA, TMS processors, image processing, OpenCV, network simulation and power electronics, electric vehicle. And from computer science and IT domains, we are offering big data, data analytics, Internet of Things, Python, Android application, data and image text mining, cloud computing, mobile computing. So in these domains, we are offering the courses and value-added program. We are conducting several programs in these areas. So which type of motivation to develop a battery electrical vehicle in India, which type of motivation we want to give to the people, to the entrepreneurs and the enthusiastic persons who have a good knowledge on research and development. So which type of motivation we want to give to the people. So domestic policy goals. So main thing is reduce the dependence on the foreign vehicle. We are all dependent upon the foreign, so we are importing the oils, right? So we want to create job we want to create this industry, this electric vehicle industry booming means automatically so many opportunities people will get, right? So job creation and economic growth, energy sources we are utilizing from the local itself. Locally we can create the economically growth. We can grow, India will grow and the people also will grow. So what the global impact? India to mitigate the climate changes. India to balance the growth, pollution control and should not repeat what the top countries done. So China and USA, European countries, while growing, they are neglecting about the global warming. So they are facing so many problems, right? If you see China or United States of America, if every year they will play, if you observe Beijing, they will like Delhi, New Delhi we are facing at winter season, like that same they are feeling due to they didn't get due to the atmospheric pollution, they are affecting, people will affecting so much. So governments around the world have allocated funding for clean energy. We need to motivate, and Paris Summit every year conducting, right? So Paris Summit. So governments, all over the world, the governments world have allocated some funding for the clean energy. We want to reduce the global warming. We need to avoid the fossil fuels. We need to shift it to renewable energy sources. So what are the challenges and what is the energy demand? Local energy sources reduce the price volatility. Automatically, whenever you are using the local energy sources, local brands, locally you can generate the power through the hydro or wind or solar. If you generate the power, you can reduce the prices also. So now the government's also giving so many benefits and so many offers they are giving. They are implementing so many schemes also. reduce export of dollars, particularly unstable regions of the world. Reduce the export, want to export the dollars particularly to unstable regions of the world. Reduce depends on few key regions, roughly 80% of the crude oil importing from the Gulf countries, right? So Saudi, Kuwait, Dubai, Qatar, Iran, from these Gulf countries we are importing the crude oil, 80% of the. So developing nations, what we want to think. Developing nations like India, what India want to think means, so lower cost vehicles will support economic development growth. That's why our Prime Minister initiatively he started Make in India program, right? Make in India, India will be great. So lower cost vehicles will support economic development growth, urban air pollution and raising oil imports to the main driver of the electrification. So if you observe Delhi, Bombay, Hyderabad, Bangalore, Chennai, Kolkata, they are more polluted, right? So from last 1 month we are less pollution happened. So the Ganga clean, Yamuna will be clean. So all the rivers they are free, they are getting less pollution only. So how to reduce the pollution in urban areas, because all the people from the rural areas they are shifted to urban areas and they are moved into the cities for the livelihood. They do livelihood, they want to survive themselves, they want to get job, means compulsory they will reach to cities, major cities or metropolitan city they will reach. Then how the people will sustain? Because here in urban pollution increasing, so now curfew removing, now every day pollution also increasing, right? So India has stated its a goal of reducing carbon intensity of its economy, but lack of infrastructure grids is a huge factor. There is no to create alternate sources, we don't have the infrastructure. When you want to start an electrical vehicle, we need to see the infrastructure, right? That infrastructure is available or not in India. Whatever the infrastructure, what are the roads, the governments are ready to accept the electrical vehicles or not, we need to think. All the government, they are ready to accept or not. Climate change. Climate change, global support for climate change has gained a momentum with India leading the way. Transportation accounts for roughly 15% of energy related to the carbon dioxide emissions globally. So that's reason in 1992 the United States ratified the United Nations Framework Convention on Climate Change, which call industrialized countries, which are growing day by day. Those countries make voluntarily, they want to take an initiative to reduce the greenhouse gases. India energy policy provides affordable energy while contributing to the India's wider social and climatic change. So India initiatively some energy policy providing affordable energy while to contributing the India's wider social and climate change. What are the drives? Key drives for electrical growth. So government funding and incentives, what are the schemes government are implemented? If suppose any entrepreneur want to start a new company, then what are the possibilities are there? Government, how the government is supporting, how the local body government is supporting to the people, we need to think. So we need to provide all the facilities, right? So we need to provide our scholars, research entrepreneurs, we need to provide so many schemes. Then only they will create wonders. So auto manufacturer, electric vehicle pipeline, the environmental consumer. So in these key drives, want to electric vehicle growth want to see. So what is my question is here? What is the saving to India on oil import if all fossil fuels, whatever the fossil fuels we are using now, whatever the coal, oil, petroleum, diesel, all the fossil fuels as per the IEEE standards, within the 150 years this will be evaporated. Then how the world will be shifted? how the world will be run, how the world will be sustained. So when suddenly we want to avoid all the fossil fuels or converted into the electric vehicle by year 2030, then how much money we can save? How much money we can save means here switching to battery electric vehicle from the IC engine. So if successfully we can shift the electrical vehicles, if suppose as per the government's initiatively, if suppose we will convert all the vehicle, automobile vehicles into an electrical vehicle, how much money we will save here? Nearly $300 billion we can save. So in oil imports, nearly here if you hear 300 billion in Indian income, 20 lakh crore in oil imports we are spending the money. So and nearly 1 gigaton of carbon dioxide emissions by 2030 as per recent report by FICCI. So nation FICCI, as per the report they given to the government as a report, we can save the money, at least $300 billion we can save. We want to shift all the automobile vehicles into a battery electrical vehicles will be shifted. The overall electric vehicle market for storage in India is likely to be 4 to 7 gigawatt in 2020. Over 50% of the market in 2020 will be driven by e-rickshaws batteries. So all the e-rickshaws are e-bikes or e-cars, electric vehicle cars, electric vehicle vehicles, and electric vehicle rickshaws also. We can achieve at the government target 50% of the market we can at least reach. So need to counter. Why we are focusing on particularly electric vehicle means need to counter air pollution coupled with raising fuel prices. So every year we are seeing, right? So every day we are observing the news. So every day 75 rupees, 80 rupees or 85, in some cases 90 rupees also it will go. Why these prices? Because of the international market in internal sense. So these prices will be varied day by day. So we need to avoid that one means we want to shift to electrical vehicles. So providing for booming business for case of establishing a strong electric vehicle market, we want to create here. We want to create in India itself by making India again. So smart cities, smart grids is promoted, which are both the right enablers for developing a robust electric vehicle market grow in India. Changing and charging infrastructure industry. If you want to develop an electrical vehicle, then how to charge that vehicle? Definitely you need charging station, right? Now we all of us are using bikes or cars or all automobile, there we are using. Then if you want fuel, right, then we will go to petrol pump. So then in future generation, when you are implemented an electrical vehicle, compulsory you need charge, right? You need to charge your vehicle, right? So then you need to alternately create charging stations also you want to create. So what are shall open up scores of opportunity for value chain players with increasing FDI and PSUs, public sector unions, and many local private sector gains also have envisaged to enter the business segment, which is promising for India in further. So with the likes of NTPC, Tata Power, BHEL, Fortum India, the growth shall be faster than the anticipated. So these top are they are interesting in electric vehicle charging stations. So electric vehicles, when you develop an electrical vehicle in the market, so the electrical vehicle business and ideas, what are the opportunities for Indian entrepreneurs? So production of electrical cars, scooters, bikes, cycles, electric vehicle charging stations, ports, spares, production of spare parts for electrical cars, scooters and bikes, electric car repair and servicing garage. When you have if suppose you people met an accident, then you want to compulsory will go to garage, right? So what are repair servicing centers? How to serve? So electrical car sales garage, electric car dealership shop, electrical car track. We can provide so many people in these areas job creation we can be done. If you are created an electrical vehicle, if you are designing a model of the electrical vehicle, you can create the market in all these areas. Whatever the areas we are discussing, in all these areas we can. Then when now you people are ready to start to design an electrical vehicle. So next question, in which we will get in mind, which is the best motor technology used for battery electrical vehicle? We have battery electrical vehicle. In electrical vehicle also, battery electrical vehicles are there, plug-in hybrid electrical vehicles are there, or fully electrical vehicles are there. So here we are discussing majorly on battery electrical vehicle. So which is the best motor technology used for battery electrical vehicle? So if you see, we have so many motors, right? So all the vehicles, they are running with the AC motor drives. Then which type of motor you people choose? If suppose we have Tesla cars are there, Benz cars are there, Volkswagen, Renault car, Kia motor, Nissan Leaf. So we have so many varieties are there. Then which, suppose if you want to start an entrepreneur, if you are a entrepreneur, then which type of motor you will choose? Whether you will choose induction motor, whether you will choose permanent magnet synchronous motor, whether you people will choose permanent magnet synchronous BLDC motor, brushless DC motor, you will choose. Which type of motor will give more efficiency? When you choose the motor, then you want to think now. Compulsory, you need to raise the question, which is the motor will give high efficiency or not. Whether when you are developing an electrical vehicle and economically people you want to reach, right? If you are developing a car, it will be applicable to up to luxury people, means no one will be benefit, right? You want to reach the market, middle class people, lower class middle people also. If they are ready to purchase your vehicle, means then you are successful. Then you will be a great successful person in that business. So types of motor used in the electrical vehicles and why BLDC motor. So here battery electrical vehicles, types of motor, what are the motors used in electrical vehicles, why BLDC motor are widely used now. Now the present world, there are many but mainly 5 different type of electrical motors which are being used in current and upcoming future also we can use in electrical vehicles. BLDC motor, brushless DC motors we are here. What are the different type of electrical motors? Brushless DC motor, permanent magnet synchronous motor, AC induction motor, and interior permanent magnet motor, permanent magnet switched reluctance type of motor. So we have 5 type of major motors. Then you people, which type of motor you will choose? Then you want to justify now. When you are selecting a BLDC motor, then you want to justify why not induction motor? Why not induction motor? Why not permanent magnet synchronous motor? What is the benefits you will get when we are using the BLDC motor? You need to analyze those things. Then BLDC motor, what is the, if you look at here, brushless DC motors are being used in most of the lightweight 2-wheeler and 3-wheeler electric vehicles like electrical scooters and electro motorcycles. If you observe here, this is a small BLDC motor which will give 24 voltage, and here the current drawn from here 27.4 amperes only. And current draw at no load condition 2.5, rated torque 190 Newton, and speed up to 2500 RPM, efficiency more than 75% we can get, but the weight here it is very less weight only, 4.10 kg. And reversible, yes, it will be reversible also. For example, in electric scooters, Ather Energy scooters. Ather Energy is a company, they are providing electrical scooters. Upcoming TVS CREOM. Upcoming TVS is company there, right? So TVS motor, they are promoting TVS CREOM type of motor. 22 motors and Hero Electric, New electric scooters, Yamaha EC03X. So in all these electric motorcycle, whether it is a 2-wheeler or 3-wheeler, we are using now the current situation I am telling. So here we are using brushless DC motors only. And here, for example, in electric motorcycle, torque motors are there, e-motion motors are, Menja motors, and Chinese Evoque motorcycles in all rickshaws and e-autos. So in these motorcycles we are using. But why BLDC motor used in electrical vehicles? But we are discussing all the automobile industry. Now the electric vehicle which are working, they are utilizing only BLDC motor only. But we need the importance, right? We need the important. Why BLDC motor? Mean in comparison to the asynchronous machines. Previously we have DC machines and asynchronous machine. In the asynchronous machines also we have squirrel gauge. Most of the case, most of the industry they are preferring with squirrel gauge type of induction motors only. Squirrel gauge type of induction motor only they are preferring. 80 to 90% of the industry they are dependent. Now in the electrical vehicles compared to the asynchronous and AC induction motor, BLDC motors are more expensive. So we want to purchase a more expensive to manufacture, but they are very efficient, 85 to 90%, and lighter in weight, compact in the size. Size also will be reduced when you are making a product on BLDC motor. For your particular electrical vehicle, whether you want to develop an e-rickshaw or e-vehicle or e-scooter or e-auto also, then you are preferring one motor, right? If you are developing, first you need to design the motor, right? You need to design, then you need to test the motor. So here by using the BLDC motor, we will get more than the induction motor. We will get more efficiency, but to design and to develop that product, it will be manufacturing stage, it will be more expensive. And to control the speed and the reverse function, that the AC motor simpler. So in asynchronous machines, that means induction motors, that reverse function compared to here, it will be very easy. So here most of the BLDC motor for China, it has become easy to produce brushless DC motor in huge numbers currently. China, they are occupying the market. ZF company also in Hyderabad is there. So they are producing electric vehicles, and China is producing low, medium and high powered BLDC motors. High power BLDC motor for electric vehicles in huge numbers and supplying all over the world. So motors like PMSM and interior PMM permanent magnet motors are much better in efficiency with no torque, ripple less noise than BLDC, but they are more expensive. When you are developing a motor or car, then you need to think, right? Economically you need to analyze, right? If you are design and you are introducing in the market, then you people will say 10 lakhs, the cost of the vehicle car is 10 lakhs, then how the people will purchase? All are not affordable, right? So you need to analyze the economical conditions of the people. You need to reach the market means. Then few years back, Tata, they are nano cars producer, right? So, but they are not sustained in the market. But they are giving one thought to the people or to the entrepreneurs. They are giving one thought, right? So like that we need to think. And then BLDC motor, they are more expensive to manufacture. So due to more availability and good performance, BLDC motors are being used in almost every light vehicle. All the light vehicles we are using. Cost of BLDC motors in India, as per the analysis, generally most of the BLDC motors we are importing from the China. If you observe in local market of China, the cost will be maybe different. But when they are we are importing, right? We are importing the motors to India to develop our vehicle means. Then the cost of 900 watt BLDC start from 2,200 rupees. And 1 kilowatt starts from 2,400, and 1.5 kilowatt, 2.5 kilowatt, 3 kilowatt, 4 kilowatt, and so on. Now, exact rates I didn't mention here, but as a different market. Suppose in Hyderabad, the motor rate is different. And in Chennai, depending upon the market and the people mindset and the dealership, who are selling the product, they will be maybe increase or decrease also. But as per my analysis and our team analysis, we said these are the cost values. And currently the cost of BLDC motors and its controllers are high in our country because most of the product we are imported from the China. If you observe in China, it may be decreased. So what are the alternatives to BLDC motor? AC induction permanent magnet synchronous motor. So if you want to deeply analyze the permanent magnet synchronous motor, permanent magnet BLDC motor, brushless DC motor, right? You can go with R. Krishnan, IISc Bangalore professor. He written on deeply, and he given the good clarification about the permanent magnet, synchronous BLDC motors, and PMSM motors also. Interior permanent magnet, these are the three are the alternatives to BLDC motor. Many electrical vehicle manufacturers using PMSM, interior PMM motor, permanent magnet, but they are not widely available for individual companies. Suppose you people are individual and we don't get the market, because here we are not producing, here we are not, the market is here not available. So as conversion of kits for other purpose, but BLDC motors are widely available for conversion of the existing IC vehicles into the electrical. As of the market scenario, BLDC motors are more available because they are producing China in their market, they are producing more BLDC motor. They are not promoting PMSM or interior permanent magnet motor. If they are promoting those motors means we will get those motors also. Then we can easily select which motor, if BLDC or PMSM or interior permanent magnet motor, we can select easily to remove these ICE combustion vehicles into an electrical vehicle. If you observe, this one is the PMSM motor. Types of motors used in PMSM motor, and match also being used by many electric vehicle manufacturers for their high performance electric motorcycle, electrical cars, and the electrical buses also. These type of PMSM motors, they will give high power density. Actually, in real time, now we are discussing about only up to single phase and three phase motors only, but the whole is running with, actually they are running with 15 phase type of induction motors. You know, United States of America, United Kingdom, the people they are using in their ships, cruise ships, they are using 15 phase type of induction motors. 15 phase induction spiral gauge type of induction motor they are using. So multi-phase motors also, depending upon the entrepreneur and their thoughts how to develop an electrical vehicle, electrical scooter, they want to design, they want to select, right? So here we are giving some thoughts itself. So manufacture for their high performance electric motor and electrical cars and electrical bikes. For example, electric motorcycle, Energica motors, Brahmo, Impulse or type of motors. For example, in electrical cars, this one Chev Bolt electrical vehicle, this one, and Nissan Leaf electrical vehicles are there. Upcoming hypercar, Pininfarina, battery 0 to 100 km in less than 2 seconds. Within the 2 seconds, it will catch to 100 km per speed. So, for example, in electrical car, electric buses, Tata Ultra, Urban, they are producing this type of motor. So, Brahmo Impulse R type of, this is the model design of an electrical motorcycle. Motor type here they are using permanent magnet AC motor, which is water cooled. If you are in water also, it will be okay. Motor controller Sevcon generation 4 and peak motor power. The motor power is 40 kilowatt and 8200 RPM, 54 HP. Peak torque here in this type of vehicle 63 Newton meter, and final drive direct chain drive. Transmission IET 6-speed gearbox with multi-plate hydraulic activated wet clutch. So the emissions are very less. So in this Brahmo Impulse R type of vehicle, they are using this type of. So what is the battery capacity here? Battery type Brahmo power BPM 15-90 lithium ion type of battery. When you are making a product, when you are making an electrical vehicle or electrical vehicle design, then here the battery you need to think, right? So in that battery we have 4 type of batteries mainly. Lithium ion batteries, lead acid batteries, nickel metal hybrid batteries, nickel cadmium type of batteries are available. So here they are using lithium ion batteries, and the battery pack capacity is 9.31 kilowatt hour and maximum is 10.2 kilowatt, and battery backup voltage is 103.6 voltage, recharge J1772, and here the level 1 maximum charging time 8 hours it will take. If you go with level 2 charge, when you want to charge, actually normally if you people observe, we are observing, right? All our mobiles we need to charge, means it will take 100% charge at least 2 hours. Then when you are making a product, real-time electrical vehicle, then how much time it will take to charge the fully battery? You need to charge fully the electrical vehicle battery, then how much time it will take? So level 1 charging stations also different. Different type of charging stations are there. 8 hours it will take. Level 2 if you go with mean 3.5. That means AC charging stations are there, DC charging stations also there. So 101 volt AC and here one level 1 adapter included, and every 10 minutes of level 2 charging adds up to 5 miles of range. And the performance here, maximum speed 100 plus and driving range is 121 miles here you can go with. In highways 56 miles and combined 77 up to goal. Nissan Leaf type of car. If you observe this data as per this electric vehicle database.org, we can take these references. The range of this car is total range is 155 to 325 kilometer, and performance of this car top speed is 144 kilometer. Power, the battery backup here, actually if you observe our mobile devices, our mobile device capacity, mobile battery capacity up to 3500 milliampere only. But when you want to go with real-time product, electrical Nissan Leaf type of electrical vehicle, here 110 kilowatt. Electric car range is 220 kilometer. Battery backup 40 kilowatt. So maximum battery backup is 40 kilowatt type of battery, usable for 36 kilowatt. Here chargeable level 2 type of converter. So these are the inferior type of motors we are using, and here AC type of motor. These are the Tesla road set, Tesla Model S type of car, Tesla Model X, Mahindra E-Veto, Mahindra E20, Mahindra E-Supro, and Tata Tiger and Tata Tiago. These type of cars, they are using AC induction motors only. So permanent magnet switched reluctance type of motors, they are using this type of vehicle. Electrical range up to 260 km. Here the battery backup is 50 kilowatt. So what are the innovative thoughts we want to give to the people? Regenerative braking. Now one more research area, regenerative braking is a new technology now to battery electrical vehicle manufacturer, and should be part of design to have extra mileage for battery electrical vehicle. So cycles and bike can reach up to 200 to 250 kilometer charge. Rickshaw can charge up to 300 kilometer charge. Cars can reach up to 400 to 500 kilometers. So next is the fast charging, right? You need to charge your vehicle within the less time. If you go with DC charging station, you can charge your battery within the 15 minutes. So fast charging is a latest concept. You can go and focus on research area, and where all battery electrical vehicle manufacturers are offering 80% of the charge battery in 15 minutes. So if this is included, it will be the big boost for the people to go for battery electrical vehicle rather than worrying about battery going down. Here, what are the challenges we feel? What are the challenges we will face? Mean charging infrastructure. Right? Is the Indian government, they are providing the infrastructure or not? Infrastructure for electrical vehicles in India has not been developed yet. There have been an initiative to set up a community charging stations, as in the case of Plug in India, facilitate charging stations. So here, if you observe here, on 22nd May 2018, Ather Energy is a automobile company, has launched its charging infrastructure service in Bangalore. But there is no that at the time there is no that much growth in the electrical vehicle market. So then the people, they are getting some losses, and Ather Grid, they are started to their own electrical scooters. They are open to all electrical vehicle, but it has been deployed where Ather plans to launch its own electrical scooter. So they are getting losses, right? So then at the time there is no market at that time. So then the company people will start electrical scooters to save that electrical charging stations. So the following companies are involved in setting up of electrical vehicle charging: Ather Grid, ACIM, Delta Electronics, ABB, Fortum India, Magnet Power, Geopoint E-Mobility, Midgrid. These are the companies they are offering. So electric will very high, mainly due to the cost of lithium-ion cells. The battery packs are imported and cost is a lot. Reasons why we need to shift, the reasons for the shift to clean mobility. Air quality, right? Mainly we are focusing on air quality indices related to India indicate that the air in many cities of India is no longer healthy to the people, to the further future generation. The air quality is pure bad. So we need to change these things. So one of the causes for this aspect related to global warming needs a shift to automobile solution that reduces, they do not produce greenhouse gas emissions. The need to reduce dependence on a fossil fuel based economy in India's crude oil imports for 2014 and 15 was $112 billion. So as of now, we are importing, every time we are importing the Gulf countries, right? In 2014 and 15 Indian government report, they are paying 112. So $112 billion they are paying. So we need to government initiatively taking, the government, they started FM phase scheme 1. The government started faster adoption of manufacturing hybrid and electrical vehicle scheme, which provides incentives for purchasing electrical vehicles. Government is releasing tenders to increase the charging infrastructure in the country. So Karnataka government approved electrical vehicle and energy storage policy in 2007. The vehicle, whatever the vehicle, if you are purchasing, they will give some incentive to, because we want to change the people mind. Immediately we can't implement suddenly electrical, they won't purchase, right? So we want to change, we need to give some offer, some incentive to, if you purchase an electrical vehicle, we want to give some design. So if you observe the battery electrical vehicles last year, 2019, John Goodenough, he got the Nobel Prize. These three persons, the professors, American professor and Japanese professor, they got Nobel Prize on by developing lithium-ion batteries. Their research is in their research, and Nobel Prize last year they got the people, and which converting fossil fuel car to an battery electric vehicle. What are the components you will remove? Removal of components from the petrol car: engine, starter motor, gear shifter, and clutch, flywheel, alternator, fuel tank and lines, air filter, exhaust system, pipes, muffler, lambda sensor, catalytic converter, mechanical. These are all the components you can remove, and you can shift it to battery electric vehicle. The weight of the battery electric vehicle also will be reduced, right? The size of the battery electrical vehicle will be reduced, means automatically the cost will be reduced. So diesel engines, if you observe what is the efficiency of IC engine and battery electric vehicle, if you observe here, diesel engines up to 35% in best point. Gasoline engine up to 30% in the best point. In real life, average about 25% for drivetrains with diesel and about 20% for those with gasoline engine. If you are going with electrical vehicles, have several advantages over conventional ICE vehicles. So energy efficient electrical vehicles convert about 79% to 82% of electrical energy from the grid to power at the wheel. So they will easily convert. So what are the companies in the electrical motor? The motorcycle companies started operation under Make in India program: Ather Energy, Atom Motors, SVM Bikes, Ather Energy, Torque Motors, EM Flux Motors, Menja Motor. These are started motorcycles and pure electrical vehicles. So bicycle co-started as of Make in India program. The following companies have launched: Ampere Vehicles, BLDC Motors, E-Bike India, and Eco E-Trio. So we want to start designing a Matlab. We want to start the modeling, means then what are the things are there? What is Matlab Simulink? So Matlab Simulink have a big opportunity in automobile industry. We need to develop we need to design a model of the car, or model of the battery, model of the converter topology or inverter topology, or motor, whatever the motors we are discussing. We want to design the motors, means compulsory we need Matlab. Matlab have some good features in all these areas. We can automobile industry, aircraft and spacecraft, dynamics and systems. In all these areas, ship systems, biological, artificial intelligence, deep neural network, and fuzzy logic. So we have several number of toolboxes are there in Matlab solutions. So by implementing, if you are choosing to design an electrical vehicle, then automatically you want to start to design a motor. Suppose a PMSM motor you want to start, then you want to control the speed of the motor. Then what are the feasibilities you want to take? So here we will see one BLDC motor, one PMSM motor. Here we will see here this one is a PMSM motor. permanent magnet synchronous motor. Here we are designing. If you observe here, we are giving a feedback path. Look at here. This is a PMSM motor, permanent magnet synchronous motor we selected here, and here I took one universal bridge from the library. If you go to library, from the library we select one universal bridge, and from that universal bridge I took MOSFET switches. So you people know well, right, why MOSFET, why IGBT means low and mid in all the automobile industry, smart electronic devices, laptop, electronic gadgets. In all the cases, most of the cases we are using MOSFET switches only. In MOSFET switches, we have, if you observe here the library, we have several number of toolboxes. So many people already know about Matlab very well. So here number of toolboxes are there. So here now we are so many now the math works they are introduced 2020A also. Here we took MOSFET switch. So why not IGBT? Both are voltage control devices only. Why I am taking MOSFET switch means, so in all the automobile industry they want to in battery management system or DC-DC converter topology or inverter. They were preferring most of the cases MOSFET because compared to the IGBT, MOSFET cost is very low and it will give more efficiency also. It will give more efficiency. We can operate these MOSFET switches. We can more than 200 kilohertz frequency also. We can operate MOSFET switches. So that's the reason here I took one universal bridge and I selected here 3 bridge jumps and MOSFET devices, and here I connected to one PMSM motor. The DC input voltage here I am giving. Here 3 bridge jumps I selected, and the snubber resistance I took here 5000, and snubber capacitance 1 microfarad, and resistance 1 millihenry I am taken, and MOSFET diodes I am selecting. Then another more advantage of MOSFET is here 0 voltage switching, 0 current switching is possible. In IGBT switches it will not possible. If you are testing both devices means initial stage MOSFET only, later they developed IGBT switch they developed, but it will give IGBT devices we can utilize in a high power application, more than 1000 volts, 2000 volts in grid connected system. We can use IGBT devices means it will give more efficiency, but in low power less than 1000 volts and 500 watt or 1 kilowatt we want to develop now, at that time if you prefer MOSFET switch means, and it will give more efficiency, and the switching power losses also compared to IGBT here very less. In MOSFET switch cases the MOSFET power switching power losses will be very less, and here I took here 160 voltage I took here, and I am giving this input voltage to here. This one I given, and the PMSM motor I select here. Then I connected to one bus selector. I connected. So from this bus selector we can observe what are the measurements are there. So permanent magnet synchronous machines, we have to find, if you observe the difference for a synchronous machines or asynchronous machine, the only difference is here these machines they will run with only synchronous speed. If you observe the asynchronous machines, they will run with the rotor speed and the synchronous speed. So here we need not to calculate the slip also. In asynchronous machines compulsory we need to mention rotor speed and synchronous speed. There rotor speed always less than the synchronous speed. If the rotor speed is equal to synchronous speed means the machine will be in ideal condition. So here this machine will be poor different, and here what are the bus selector taking by connecting the bus selector here stator currents, Hall effect signals. So why we are placing the Hall effect sensor signals here means, so to identify the inside of the rotor currents, inside of the rotor position we need to identify, then we are placing with Hall effect sensor signals. So by selecting the Hall effect sensor signals, then here we connected one more bus creator we done here. Output as bus we created, we selected Hall effect signal A, Hall effect signal B, Hall effect signal C. So then how these signals will be converted, decoder we are done here. Then how these will be done, look at here. If you observe, mostly here if you observe, Hall EMF signals. Here if you observe here if you observe this one in a PMSM machine, we took here Hall EMF signals. From that Hall EMF sensor signals, the Hall EMF signal here HA, HB, HC we selected. Then from that HA, HB, EMF A, EMF B, EMF C we are getting. So then how it will be converted? Here we are taken AND gate operation. AND gate we are taken. Then these 0, 0, 0. This one is BCD code, right? 842 people know well, I think. Digital electronics. From this digital electronics we took here. If you observe here 0, 0, 0, 0, 0, 0, okay. So then how it will become? 0, 0, 0 will come, 0, 0, 0, 1 will come. HA, HB, HC, right? These Hall sensor signals we need to convert. Whenever you are giving the supply to the stator side, then the induced EMF will be produced, right? So then the current will go, then some magnetic field will be produced, then induced EMF will be produced. So that induced EMF, how here we are digitally maintaining 0, 0, 0 and 0 minus 1 means, then here, look at here, just 1 minute. I will show, I will take one example whether either 0, 0, 0, 1 up to 0 to 7 are there. So from that we took here, I will try to explain here. If suppose if I have to here 0, 0, right? So HA, HB, HC, right? So here 0 to 7 are there. We know the BCD code, and here we are converted induced EMF A, induced EMF B, induced EMF C we are converted, right? Then how it will be converted? Suppose if you observe 0, 0, 1 we will take here. Then first you need to take HA, HB. Then you need to take HB, HC. Then HC, HA. Suppose HA, HB you will take. HA, HB if you take mean, then HA, HB bar, HB, HA bar and HB you need to give. What is the HA? HA here we took 0. Then HB bar will come to 1 and HA bar will come 1. So HB will come 0. So if you know the AND gate operation, you people, everyone will know, right? In AND gate operation, so both are in equal, right? So both are in 1, 1 only, we will get at output side 1. So 0, 1 operation in AND gate operation, we will get 0, 1, 0, we will get 0. So this one take positive, this one take now. Then sum this one. So here we will get 0 only. That means here I am getting induced EMF A 0 I got. Then I need to shift induced EMF B I need to shift, right? So here, right, HB, HC I need to take. So here HB, HC I am selecting. Then what is HB? 0 and here 1, right? HB 0, HB, HC bar and here HB bar and HC. So HB is 0 and HC bar will get 0 only. 1 becomes to 1 bar means 0 and HB bar how much you will get? HB bar 1 you will get already H. So in AND gate operation this one will be 0 and this one will become 1 and here positive and here negative will come. Output side you will get minus 1. So here induced EMF B you will get minus 1. Then see here induced EMF HC, HCA we will observe here HC we are taking 0, 0, 1, right? HC, HA bar, HC, HA bar, then HC bar, HA. HC, what is HC? What is HC? 1. HA bar will become 1. Then HC bar 0. HA bar will become 0. Then 1 1 we will get 1. Here 0 0 we will get 0. Positive, negative. Here we will get what we will get here plus 1 we will get. If you observe here what we are doing here, if you observe here, same 0 0 1 we select, right? If you observe here, I am closing this one. 0 minus 1 plus 1 we got, right? If you observe here 0 0 1, I hope you people understood. 0 0 1 we got 0 minus 1 plus 1 we will get. Then these same all the 0 to 7 we took here, and here not get we took. All EMF signals, that bus will be go to here. If you hear 0 means 1. HA bar, HB bar, HC bar. Here HA, HB, HC. This is simple model only we took for understanding for that one. So AND gate operation we took here. Then come back here. Then EMF, induced EMF A, B, C we got it. Then we converted that one into gate signals. Gate signals, we need to give the gate signal, right? Switching signals, we need to give the inverter. Then only the DC input voltage will be converted into the AC. Then this permanent magnet synchronous machine will be rotated into the will be rotated, right? So we need to convert DC input voltage. I am giving 160 voltage. So that 160 I need to convert into AC. Then here we took greater than relational operator, greater than 0, less than 0 we took here. EMF A, EMF B, EMF C. If you observe Q1, Q2, Q3, Q4, Q6. These are the switching patterns. If you observe the operation of three-phase inverter, if you know, I think most of the people they will know, right? So in 120-degree conduction mode is there, 180-degree conduction mode is there. So the switches, 6 switches. In each leg we need to operate only one switch, right? If you want to operate 1, 3, 5, 2, 6, 4, this is the combination, right? So 6 switches, total how much degree? 360 degrees. So in each leg, in each switches we will need to maintain 60 degree, 60 degree. So here the motor position we need to identify. That's the reason we are inside of the motor. We will place all EMFs. This is a model in the loop. In Matlab Simulink, when you want to make a real-time product, we need to follow 3 steps. Model in the loop, software in the loop, hardware in the loop. So this is the model in the loop. You want to design your motor and how much speed it will be rotated. Then by placing a PI controller, we are giving from the output speed here we took 35 radians, we are converting into the RPM. Then we connected to one sum block. This one is the sum block, error block, and here the reference speed here I am giving 1500 RPM. Then with the PI controller I can run this vehicle means, then we will see here. It's a simple basic model only. To understanding purpose we will teach this one. And what is the converter topology? In real-time converter topology, micro fuzzy German and KPIT people, they are working on electrical train. E-train Sweden company, they are typing, and air buses also, electrical buses. They are moving. Then they are proposing advanced converter topology, isolated converter topologies also they are preferring. But why this much advanced converter topology they need means they need to convert, right? They need to convert the high voltage to low voltage. They need to maintain high voltage battery. Suppose if you take the battery capacity 40 kilowatt battery, if you take in our electrical car, then how to maintain the voltage levels from the source to load side? You need to drive your car, right? Then how to maintain means compulsory you need advanced converter topology, DC-DC converter topology. In that case, if you go with advanced isolated topologies, resonant type of converters, dual active bridge type of converter topology, they will give high efficiency. Isolated topology compared to the non-isolated topologies. All the non-isolated topology converters, they will applicable up to all the whatever the devices, mobile devices, TVs or laptops, notepads we are using now. All those devices we are using non-isolated converters only. So when you want to use a high power drive application, suppose JCB you want to run. So these type of motors will help. JCB, Procline, heavy, how the trains they are moving. Previously, bullet trains now we are getting one that bullet train, electrical trains, right? So in the train now, the motors, how to control the plobal, onboard chargers, off-board chargers. So we need to analyze the converter topology. If you are getting a project, and means the companies, whatever the automobile industry companies, Tech Mahindra or Tata Industry or KPIT or Microfaji, Renault company or Ford company, Benz company, whatever the companies, they will offer, you are expecting Tesla Motors or Texas Instrument, they will offer whether you people will develop a converter topology, a new converter topology, whether you people will develop or not. So they will think like that. So they will think, and you people want to, so whatever the converter topology, we have so many converter topology, we need to focus advanced converter topologies. Advanced converter topology, whatever here we are seeing 3-phase inverter, 3-phase motor. Previously I am telling 15-phase type of induction motors. Then for that ship, we need to give 15-phase type of induction motor main. Then you are operating that ship, big ship, with a renewable energy application. Suppose standalone solar energy created, standalone and hybrid energy you are generating. Then you need to control the flow, right? From the solar panel you are getting the renewable energy, DC only you will get. Then you need to convert that DC into AC in that crude ships. Then you compulsory need inverter, right? Like this here, we are using 3-phase inverter, but when you are working on 15-phase type of induction motor, then how much type of inverter you need? 15 level compulsory, 15-phase, 15 level type of inverter topology you need to implement. So multi-level inverter topology is also there. Electric T-type multi-level. Now in initial stage, neutral diode clamped, flyback capacitor based type multi-level inverter and cascade H type of bridge multi-level. Now the current trend, T-type multi-level inverter, K-type multi-level inverter, C-type multi-level, selective harmonic elimination type of multi-level inverters are. If you observe here, whatever we are giving 1500 now, if you observing here, by giving the 1500 I am giving, then at DC input side I am reaching 1499. Then we will see here what is the speed, how the speed waveform we will analyze here. Speed waveform if you observe here. So in all the cruise, so multi-level inverter, selective, we discuss on multi-level inverter topology also there. Isolated topology, bidirectional converters also. You need to run your vehicle in forward and backward. You need, right? In electrical traction motors, they were using bidirectional DC-DC converter topology. Why the express trains when they are starting initial stage? When I am discussing here, some vehicles within the 0.5, within the 5 seconds or 9 seconds, they will pick up 100 km speed. Like that, if you observe the metro trains or passenger trains, initial stage itself they will pick up with high amount of speed. Then why these express train they are not take high amount of speed at initial stage? Means because the construction, how to design the model. When you want to develop a model, you need to analyze all the questions. You need to analyze the questions and you need to think from that as per your analysis and as per our team our analysis. We need to conclude that one. Here, if you observe the waveform, here, if you see here, I think every people visible. It is started from 0 and it reaches to 1500 RPM, right? It is started from 0. It is started from 0 and it is up to reaches to 1500 RPM, right? So at initial stage it is started 0, 1500 and it will be settled to 1500 RPM. You can control the speed of the motor. You can easily control the speed of the motor. You can control the speed of the motor by giving the feedback path. Now we are running the vehicles, right? Whenever any obstacles comes in front of us, we are applying the brakes, right? Then how you people will reduce the wheel speed? Whenever you are trying to reduce the wheel speed only, you can reduce the vehicle speed. So the vehicle you need to maintain. So the wheel radius, how much brake you are applying, how much force you are applying, these are all the things you want to consideration when you want to design an electrical vehicle. Whether it is a battery electrical vehicle or plug-in hybrid electrical vehicle or fully electrical. So battery management is success. We have 4 type of parts in the battery electrical engineers. We have 4 type of thoughts. So battery management, whether you want to choose a lithium ion battery, lead acid battery, nickel metal, BMW i2, i3, Audi A6, they are preferring with nickel metal hybrid type of batteries. They are preferring with nickel metal hydride. They will give more high power density. But Tesla company, they are offering the battery cost will be lakhs. So then they are putting the price 10 to 12 lakhs. Initial cost of the car, they are putting 10 to 12. If you people are developing an electrical scooter, then you are giving low amount of means, then you can create a market. You can create wonders in the market also. So here we are selecting 1500 RPM, we are getting. Then if you observe the torque Newton meter, up to here we are giving step time 0.1 only. It reaches to up to 0.1, it reaches to near 12. Here if you observe the torque Newton meter, the step time load torque value we are giving 0.1. So then it reaches to some peak value and it will be oscillated and near to 0 and it comes to settle here. Torque Newton meter near to 1.4 Newton meter we are getting here. Then if you observe here, the stator current, how much you are getting. If you see here, this is the stator current we are getting. How much? Near to 4 amperes we are getting. It is peak value and it reaches to some peak value. I hope everyone gets some knowledge. Thanks for attending. A special thanks to giving this opportunity to VNRVJIET, Vijnana Jyoti Management and HOD Madam and Coordinator Sir. A special thanks and thanks to Director Sir. And thanks to all the participants who are participated and who are spending your valuable time on this situation. You are spending your valuable time and you are giving some feedback. So those people who are come newly, subscribe our channel. We will update it every weekly updates we will give, and give the comments below and subscribe, fill the feedback form and give your valuable feedback. And once again, thanks to VNRVJIET management. Department of EEE, Electrical and Electronics Engineering. Thank you. Thanks to Pantech Management. Thanks for associating with us, VNRVJIET. I hope you people will get some knowledge. We are giving a brief idea about battery electrical vehicle only. We are not touch any history of electrical vehicle also. If you want a history of electrical vehicle, origin of electrical vehicle, when it started, we already in this, if you go with our YouTube channel, you can search electric vehicle also. At that point we discuss about history of the electrical vehicles, which type of motors we are discussing, and there we discussed a new converter topology, advanced converter topology, dual active bridge type of converter topology we discussed in the forward direction and the backward direction. The power flow, how the power flow will go from forward and backward direction, we given that one. And I hope you people get some knowledge. Give your valuable comments and subscribe our channel. If any mistakes I done means, so give the comments means we can rectify easily. And once again, thank you management of VNRVJIET. Thank you madam. Thank you sir.